Okay, now 3:30 p.m. So can we start? If you can start, you can give me thumbs. All right. So thank you. Okay. A lot of notification. All right. So we can start now. Hi everybody. Once again, thank you for joining us in ILSA's Conference of Learning and Development 2021. So you will be with me in these mini classes for the topic integration of battery energy storage system into grid connected photovoltaic system, GCPV system. So hope everybody can hear me, and if you have any question, we can put all your question for the end of my session for today. Okay, I see here that we have how many participants? 45 for us to join in my mini classes. Thank you. And I would like to introduce myself. Okay. Change this one. Okay, so my name is Muhammad Khairul Fikri bin Muhammad Saleh. I'm from Kuala Lumpur. My education background is electrical engineering, power. I just finished my MBA this year. And I'm also a professional engineer, electrical field, and also professional technologist in green technology field. Okay, I start my career with IBC Solar Technique since 2009 until 2013. So in that company, my role is to design, to implement a project, and also to commissioning the solar hybrid system. So most of my experience in that company is solar hybrid technology. And then I have opportunity to join Tenaga Nasional Berhad, TMB. 2013 started, and I was placed in TMB Integrated Learning Solutions Berhad ILSAS. So my role at ILSAS is training engineer, renewable energy and energy efficiency. So anything regarding on the training for renewable energy and energy efficiency is conducted by me and my team lah. I see in this this room also have my team will support me. If any question regarding on this topic, they will be here to help me lah. Okay, so other than renewable energy and energy efficiency, we also conduct a training for the new technology, such as for this technology, battery system, BES. Also have a hydrogen fuel, electric vehicle, and others, energy trading and others. Okay, so that is a little background about me. So I would like to go further for this course, mini course lah. I think mini class lah. You see, so I hope that everybody of you can explain a basic knowledge, regarding on this battery energy storage system that will be integrated with the grid connected photovoltaic system, or it's called GCPV lah. Okay. So they have two main topic in here. Just a short one, because we have 1 hour session for today. So it just an overview the global content of the battery energy storage, and also this is the part where we want to look over for this battery energy storage system that installed in our training facility at TMB ILSAS. Okay, so I will share this this technology that we are install this BES into our existing system for the GCPV system at our training facility. Is after this I will explain you further. Okay, so if you have any question, you can keep your question after I finish all my slide today. Alright. So everybody can hear me clear or not? Can someone respond? Is there anything in the chat? Okay, clear. Thank you. Right. I'm sorry if anything not clear. Mr. Zarif, my team can notify me. Yeah.
Okay, Chef Iclad. If anything, I will notify you later.
All right. Thank you, Cik Zarif. Okay. So we start on the global context of the battery energy storage. Okay. I want to share one of sorry. Stop sharing. Sorry, I have to share. Okay, this one I think. Hold on. They have a link to show the battery project around the world. Okay. Okay, you can see my.
Okay, Chef Iclad. We can clearly see that.
Okay. All right. So this is actually one website. They can show the existing project and also the future project that have around the world. So when this is they have the link for that is the battery innovation.org. You can see where is the existing project in the world. For example, I just click one of the site in here. They have a 2 megawatt system at Japan using the lead advanced lead battery. Okay, so they have commissioning this project 2015, and this project purposely for the to generate the battery into the utility scale. Okay, this is for one example lah. So this the brand of this battery is Hitachi. So they also have some we call the future or in development of the battery storage in China, for example, for this one at this location. So in this one is very big, 20 megawatt system in for 160 megawatt hour in generation. So they use lead carbon battery, for example, for this one, and this commissioning for 2017 means that this they have commissioning this, but they are using Narada battery. So you can use this this link to show to see, okay, to see there are a various project in the world are using the battery technology right now. So maybe in Malaysia, this is the started to it's called to reach to have a research and also to find a way how to implement this battery in our country lah. Okay, so this is just an I just want to show you there's a lot of project. I think the big scale project in the around the world for this battery energy storage system. Okay, so I back to my slide. Okay, so this is the link. If anyone to I can paste this after this. If anyone want to see the website, I can share with you in the chat room. Yes, chat room. So for the battery energy storage application, this is just a overview for this system. Uh, we can categorize it for the residential and small application, and the commercial, industrial, and also the utility application lah. So first, I just want to brief regarding on this residential and small scale application. So we can see that in here the application for this BES is for the solar self consumption. If you know, in Malaysia we have some, it's called some initiative. If someone who want to install the solar GCPV system, they can choose whether they want to use or you want to go for the net energy metering. It's called NEM, or you can go for the it's called a self consumption selco. For the two apa initiative. So if let's say there's these people who doesn't want to go for the net energy metering, so they can use this battery energy storage system into into their solar system. So for this application, they can use the solar at at morning, and then the battery the battery or the energy that have an access to, they can store the energy, into this battery system, so that they can use this energy at the night. So that is how this battery application can be coupled with this solar system. So in our our examples after this, we are using this kind of this kind of technology that installed in Iraq, also ISAS, because we have this facility in ISAS called Iraq, ISAS Renewable Energy Center. So we are using this kind of application in our facility. Okay, so another one is off-grid system. If you know that this off-grid system is used for a system is installed, is installed when the grid is not available. So this installation is normally used at the rural area, such as in the island, in the location that we cannot reach the grid system. So they are using this off-grid system, whether it's a small system or a big system that installed in that any location. So they are using this battery to give the generation in the night. They are called the off-grid system. So this off-grid system, from my experience, previous before I joined TMB, is one of the famous installation is a solar hybrid system. Okay, they also have a generation to support the system for any failure for if let's say they have a rain season, so that the solar cannot generate energy to the load, and also if let's say the battery have the DOD or depth of discharge is low, so that this generator is support this system. That's why it is called a solar hybrid system. And also, for the third one is the energy backup. I think all of you know on this energy backup. For example, for this one, using the UPS, if let's say they have an outage, so if they have any load that they need to power up to 24 hours, these batteries can help to energize or to give to give the energy to the load for the backup system. Okay, this is just a brief for the example, the application to use this battery energy storage system in this residential or small scale application. Okay, another one, I move to the commercial and industrial scale application. This is just a point that I want to highlight in here. So you can see that this battery application for the commercial industry can use for the peak shaving. You know that in Malaysia, I think also all the commercial, for example, factory, they a certain factory, they have been charged for this demand, the MD charge if they use more than what uh, they estimate. Okay, so in here they put a 30% of the utility bill may be charged for this demand charge lah. So if you have, or this factory, the industry have their solar, they are installed the solar generation, but the solar that they install in the this factory doesn't help much. So this battery energy storage system can couple with this solar to help to reduce this this load by this apa can call to use this battery to overcome this peak shaving issue. Okay. All right. So another one load shifting. They also can use for this load shifting when the electricity is cheap. We are using the solar energy to charging the battery with the solar energy. And if the battery the electricity is expensive, so that we can use this battery to supply the apa the energy to the load by using this battery energy storage system. So this is one of the application for the commercial industry. So they can shift the whether then you use the electricity for the distribution license, they can use this battery to help to reduce their electricity bill. Okay, so another one is energy backup. Also have in this application known as system security. Sorry. Is it anyone want to ask any question? Okay. All right. So another one is using this microgrid system. This is actually I just explained. Is using the solar hybrid system. The solar hybrid system is one of the system that can be used for build up this microgrid. So other than this solar and also the battery energy storage system, there are others renewable energy can be coupled into this microgrid to help this some community, for example in the island, in the island to have this energy to supply the energy to all the load around that area. So this is how the microgrids is this is how the battery storage system can be coupled into this microgrid system. That is one of the application that can be used in the commercial scale application. Okay. Alright, other than that, this application can be used at the utility side. So at the utility side mean that in front of the meter, so that they can wholesale the energy arbitrage. They can also regulate the frequency and also can support the voltage, and they also have can follow what is the load to be used, rather than like the load shifting tadi lah. Okay, and then they can reserve the capacity and also can on the local capacity they can use for backup, and then also they can integrate with this renewable energy technology to firm and smoothing the system for this RE. And also in the transmission and distribution, they also can use for this battery energy storage system. Okay, this is for the utility application. Okay, this is just some reading that we have put in here. So we can see that you know that the battery price is is very high right now. So that's why this is one of the reason why in Malaysia they don't implement this technology right now. So if the battery price can be to reduce down, so that this when the battery itself is used a lot, so that the price of the battery will be going down. So you can see that in here by 2013 until right now 2020, last year 2020, for this statistic, so the price is going down. So now for the lithium ion battery, the price is $137 per kilowatt hour. So means that when you see this trend is coming down and more cheap. So I believe in in the 2 or 3 years in the future, will be have a lot of battery in Malaysia. Okay, so in the US storage market, this is for the US. So you can see the deployment of this energy storage is keep increasing also. But when you see in the quarter, I think the last quarter, you can see the height is increased for the front of the, means that the utility side application rather than non-residential or the commercial and also the residential, means that this battery energy storage system is good for the utility at US. Okay, this is how the trend. You see, this the peak is last year. You can see that. So that means that this battery application is good for the utility application. Okay, they just show the trend. And then on the global content of this energy deployment, so in the gigawatt hour, you see that the trend also increasing. I think because of the price is decreasing, so that many people try to shift to this new technology to support all the application that I explained just now. So you can see that on 2021, 51,000 gigawatt hour are installed globally. So that the trend expected to be increased by 740,000 plus on 2030. So another how many years? Another around 10 years in the future. So mean that the battery, as you see now, there are a lot of application is a use using this battery system. Okay, so that is the just a point to show the overview on the global context. So you can try to search and to see what is the the detailed explanation on this the studies in the international and the global content. Okay, so now we are moving to the next topic. So this is one example that we want uh, to share for the battery energy storage system that installed in our training facilities called IRAC at ILSAS, ILSAS Bangi. Okay. So I have another. Okay. All right. So you know that there are a lot of type for the battery storage. So one of the type is lead acid. So if you can you know this lead acid. So the lead acid is the application actually is um, this application is using a lot in the off-grid system, in the off-grid system. Why? Because of this lead acid is cheapest than other type, and then this is this lead acid also reliable and also easily to dispose and recycle. So, for example, in my experience for the solar hybrid system, they are using this lead acid system widely, and then they can recycle back. And if let's say they have a couple, they can schedule this waste easily. Yeah, all right. So disadvantage of this lead acid, if you are using the flooded, they have two, they are flooded and also a gel. If you are using the flooded lead acid, they are required for the regular maintenance and also the ventilation, means that they have to maintain or what's called they have to the temperature. They have to take care of the temperature in the range of the limit. So they have their limit of this. They cannot exceed the highest limit of the temperature, because if the battery is too hot, so they can affect a lot of they have actually they they have disadvantage on this temperature. Okay. uh, so the lifespan normally is if you are using this lead acid, they can sustain for 5 or 10 years because they are a shortened lifespan. So if you take care of your battery in a good health, so that you can spend your life of this battery another 7 to 10 years. If not, after 5 years, the battery will kaput. Okay. So another one is the type of battery right now is the lithium-ion battery. So this is now the most orang kata the most the most people are using for this type of battery. So this battery normally are used for the small scale application. So if let's say you want to develop apa uh, a system for this BS to couple with your apa, existing solar system, this is the best battery that you can choose, because one is the battery is uh, almost no regular maintenance lah, because one this battery is also they can have a higher battery energy density, and they are longer life span for this type of battery, and here also they have a higher depth of discharge, DOD lah. But the disadvantage is more expensive. That's why when you talk about this lithium ion battery, for example, they are also used in the electric vehicle for Tesla, if I'm not mistaken. So you see that this car is very expensive because they are using this lithium ion battery, and then they also have the highest chance to catching fire, but they have if you install it properly, the chance for the battery to catching fire is close to zero. Okay, this one. Other than that, they have a nickel cadmium batteries. Nickel cadmium batteries ni normally they are used for the large scale application. So the nickel cadmium battery is durable and also can be operate at extreme temperatures. This is one of the advantage for this battery, this type of battery. So I just tell you just now that the battery for the lead acid, I think also for this you have to make sure that your battery is not in the extremely high in temperature, because they can easily kaput lah. Okay. So additionally, they don't have a required compact battery management system, and they are also the maintenance free. Okay, this is one of disadvantages, and the disadvantage of this battery is this cadmium is at apa, can produce extremely toxic, but apa, they have some country that have banned this battery, and also they have a hard to dispose for this battery lah. Okay. And then another one is called a flow battery, and then this flow battery they can 100% depth of discharge. This means that they can use 100% of the capacity of the battery. So I think the others need, they have a limit so that they can at a certain percentage they have to charge back the battery, so that to maintain the battery is not to use 100%. But for this battery, they can use for the 100% without the damaging the health of the battery. Okay, so but the battery is much expensive, so because of this technology, so that is the high price of these flow batteries. So the application for these flow batteries normally are using at the large scale installation. Okay, all right. That is the type of battery. They have a lot of type of battery. Maybe you can search by yourself for this type of battery. This is the just one better the popular battery are used in the world. Okay, so just go for DS application. So we are last 2000, last 2000, I think 2000 or 2001. Sorry, for this before the PKP, the first PKP this year, we have finished our installation for this battery system, battery energy system at our facility, training facility. It's called Iclad. So this battery system is 9,600 kilowatt hour. So they are used for the night usage. They have a load that are power up for this. The purposely power up for discharge this battery. So this battery are coupled with the existing system, the solar system in our facility. The 1.61 kilowatt peak system, single phase in our facility, so that we couple this BES system into this existing GCPV system, okay, in our training facility IRAC at Isas Bangi. Okay, so you can see this battery, they are come with one rack or cabinet. They have this solar inverter. They have this 2 unit of battery, and also they have this protection in here, and they have we are put two load power distribution unit in here, one at the top and also the bottom of the rack. Okay, this is how the battery system BES look in our facility. Okay, so when you see this single line diagram, I think this more technical. So you can see this is the existing system of the GCPV, the grid connected photovoltaic. They have the solar panel and this DC combiner box, and also they have the inverters and the existing power from the solar is interconnect into the MSB in our IRAC. Okay, so means that indirect feed lah, so that we are using a part of our load in the IRAC is come from the solar technology. Once we come the battery energy storage system, so we have one manual transfer switch that can be select either we want to use the existing system or use the new system for the battery energy storage. Okay, so actually our attention for this project, just want to share, this project is funded by TMB under TMB Green Energy Development Fund. So we are focusing on to ready this training facility for the BES to give some overview and a knowledge regarding on this battery. So we are planned to have a full course for this technology maybe next year, inshallah, so that we can see how this battery energy storage system operate in the small scale system. Okay, actually we are trying to find the BES system that can be coupled with the existing system for this grid inverter. But unfortunately, we cannot find this technology that this battery technology can be coupled directly to the existing inverter because they have a lot of thing to be done, so that they are produce they are provide us another apa this called bidirectional inverter to the new BES system. So in here, that's why they have the manual selector. Either we want to use the existing system or we want to use the new system, solar with the BES system in our facility. So they are using this type of battery, lithium iron phosphate. They are this battery use actually a small scale. I think it's not more than 100 or 1,000 watt application for the load for this battery. So we are using this Narada brand, Narada brand for lithium. So this battery is a 48 volt system, DC in operating. So this is the range of the operating voltage between 40.5 volt to 54 volt. Okay. All right. So this is the specification. They can charge the battery. The recommended charge of the battery is 20 amp, and the maximum is not more than 100 amp. So this is the range of the voltage, and the weight of this battery is 45 kg. But the battery have the slot in the cabinet, so we can we not yet to dismantle this part to see how how big or how berat this battery. Okay. So inside the battery, they have if you open this they have a cell of the battery. I think inside this they have 48 cell in one rack battery, if I'm not mistaken. And they have a connection system, protection system, also the BMS system. So good for this is called this BES system. They can see whether this they can see the malfunction of the battery. So in the display of this battery, you can they can show the fault, the malfunction of that battery. Compared to the lead acid battery or for the solar hybrid battery, the batteries cannot have this BMS system. So if you want to have this BMS system for the solar hybrid, for example, they need they need the independent monitoring system to couple with this existing BES or the technologies batteries for this kind. So the purpose that to have this inverter, because of the existing inverter cannot couple with this battery energy BES system. So they are provide the new bidirectional inverter to control the system operation. So mean that when the solar need to charge the battery, they can charge the battery, and if the battery want to discharge to the load, so they can discharge to the load. And this inverter is help to operate all the system. Either we want to use the battery, or we want to use the solar to charge the battery, or to use the utility to charge the battery. We can see the operation mode after this. Okay. All right. So other than this inverter, other than you can use the solar and the battery, they also can use utility and a generator to support this system. So they can use they can provide the energy to the home appliance depends on what capacity of the output of the inverters. Okay. For our inverter, I think how many kilowatt? 5 kilowatt system, 5 kilowatt apa appliance that can be power up using by this battery system. Okay, so there are two modes in operation for this battery system. One for the charger and another one for the output. So for this charger means that to charge the battery, they can select three mode. Okay? First is solar first. So the in the BMS system, you can choose this solar first or solar and utility or only solar for the sources of to charge the battery. If you choose the solar first, means that the solar energy will charge the battery as a first priority. So utility will charge battery only when the energy is not available. So if let's say in the night, the solar don't have the solar, so this utility can charge the battery if you choose this solar first. If you choose the default for the solar and utility, so the solar energy and the utility will charge the battery at the same time. This one you can choose in this BMS system for this BS system at our facility lah. Okay, and if you want to use only solar, so the solar is only charged. Solar is the one energy that will be charged the battery no matter the utility is available or not. This is means that the solar only solar this part lah. Okay. So that one on the charger side for the battery, this one they have a method on the operation where the output. So the output means that where is the battery energy to be discharged to the load. Okay, they have three also mode you can choose. One is USB, it's called USB, utility solar battery. Means the default setting is utility first. Means that utility will provide power to the load as a first priority. If let's say the solar and the battery power ni will provide the power when the utility power is not available. This one maybe on this if let's say they have an outage or the blackout, so the solar battery can power up the load using solar and also the battery. This is the first mode, and the second mode is a SUB. It's called solar utility and battery. For this mode, the solar energy provide the power to the load as the first priority. So if the solar energy is not sufficient to power all the connected load, and then this utility energy will supply the power to the load at the same time. And then another one mode is SPU. It's called solar, battery, and also utility. So this all this mode can also be selected in this BMS system, so that you can choose what is your priority for this output source. So for the SBU mode, you can the solar energy will provide the power to the load at the first priority. If the solar energy is not sufficient enough to power all the connected load, so the battery energy will supply power at the load at the same time, and then utility provide power to the load only when the battery voltage drop to at the low level warning voltage or a setting point in the this one is the setting lah. So means that they are using this solar first, and then they are if let's say they cannot supply the solar, so the battery will support if let's say these two source cannot supply to the load, so we can this utility can provide the power to support both of the solar and also battery. This called SBU mode. Okay. So this is where the installation is made. And then this is the load, the purposely load that we are supply using this BES system. So means this load are connected. The battery is discharged to this this load. The ILSAS logo. At the night they have a LED at the rooftop here. So this LED is powered up by this battery system in our facility. Okay. So and then the last two slide for today, last three. So I just want to share the data, just the data that we are capture last 2 months. I think last 2 months on the August, 15 August. This is a 1 day data. You can see this is when we are select the output. Priority is USB, utility, solar, and battery. Okay. This part is the voltage. The battery voltage. You can see that the previously I just shared that the battery voltage is around 45 to 40 point something voltage in that range. So this is the range. You can see. So it's in a good range. So this is the 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 charging current. And then this one is the discharge current, and then this one is the battery capacity in terms of percentage lah. Actually, it's in terms of percentage. So you can see this. The line mode is the charge. They are charged the battery using the utility. So they are charged, and then this one is discharge. So the capacity and the charge of discharge is if the capacity of I think around 30%. So they need utility to charge back the system. Okay, we can see that 30% they charge back, and then this is discharge, and 30% they charge back. This is on 1 day, 1 day, 1 day data. 1 day data. So this the load have to discharge is around, if you see it here, 4 a.m. until 4 a.m. Because of this part is apa? I think around 4 or 3 to 4 3 to 4 hours to recharge back the battery using this this mode. Okay. So this data, you will see the trend. This one is for 1 day, and then this one is when we collect the data for a 1 week, 15 to 30 August this. So the trend is the same. We'll see that it's almost the same. So means that the load that we are discharged to this logo is orang kata almost constant every day. Okay, this is the data lah. Okay, so when we select the output for the charger using this SBU, just now I just showed them this name. So you can see this is the voltage level of the battery. Is also same in the range of and then this is the mode when the this is the capacity of the percentage or capacity of the battery. So you can see this part is for the charging, and then this one for discharge, and then this when they are reaching below than 30%, they will charge back. So why they have this kind ni? Because they have the priority of the solar, just now the solar, the utility, and so this is the solar, the purple one, and then after you see the capacity of 100 in the full charge, so they are using the apa they are using the apa panggil tu the small amount of current to discharge. So means that in this one, I think they are using the solar energy 100%. So that's why after the solar, you see dekat sini dah in the evening, so so they are discharge the battery. So they are discharge battery are using this this one is solar. They also discharge the battery using the battery. So this is the 1 day data. So if you table it on the 1 week of this the system, the trend also see the same kecuali except for this on the solar part. On the solar part, this one is depending on the weather. Okay, I think this all for now. Okay, we are open for question.
Okay, Encik Fikri, actually, I already compiled we have almost about 10 questions at the chat actually. There's quite a lot of question also, which is like I say, it's a 10 question here from our participant today. However, we have a very limited time here. I believe we are unable to answer all the questions. So for those who are giving a question at the chat, I appreciate if you can also put your email address for us to feedback the question in case our presenter, Encik Khairul Fikri, unable to answer the question because we are running out of time. However, I will pick one or two questions from the chat to Mr. Khairul Fikri to answer regarding the topic today. Is it okay, Encik Fikri, like that?
Can. Okay. So
Okay. If can, I read the first question first. Is it okay?
Can.
Okay, so for the first question is from Mr. Suhardi Abdul Hamid. The question is said about the questions is about the large scale solar panels. The question is, can we use large scale solar panel using TFC, thin film solar cells? Okay. Any feedback from you, Cik Fikri?
All right. Thank you for the question. But this question, I think, is quite related for this battery technology. Because this one is more to solar, but I can answer this question. Actually, when we compare the type of solar panel, you have monocrystalline, you have polycrystalline, you have a thin film, and also you have hybrid panels. So in the world, I think the most common panel using the crystalline type, crystalline. So it's either mono or polycrystalline. For the thin film, you have to study or to design to give the best solution for this thin film, because not the new technology, the conventional thin film solar cell type, the disadvantage are the space of if you want to use this thin film type. Okay, because of the size of the solar panel for the for example for 100 watt panels, you need to use it double for 200 watt panel for crystalline type. So that's why in Malaysia they are I think not of our provider are using this type of solar panel. Other than that, regarding on the efficiency of that panel is less than this crystalline module. Okay, that's the answer for Cik Suhadi question. Okay.
Okay. Thank you, Cik Fikri. I pick another question. I think maybe we can answer one or two more question. The next question is from Arif Rahman. Okay. Okay. It says here, that's great, sir. You have been begin and implemented solar system and battery storage technology at TMB. What is your most difficult obstacles in doing that? And what's your plan in the future to support decarbonizations? Thank you, sir.
All right, thank you for the question. It's a good question. So actually, what we are trying to do in our training facility is one of to develop this new technology, yeah. Because you see that this battery technology is a part of this future technology, so that you are using this battery to reduce using the conventional generation for this one. So the most difficult thing that is one just now I just share, because we are trying to see the technology of the battery that can couple with this existing system, because of you can see that right now is a lot of residential are using, I think almost 8,000 under feed-in tariff program. I think almost 8,000 or 10,000 applicant for this feed-in tariff, this GCP system under this feed-in tariff. So if let's say they want to have the best or the apa namanya tu additional, so you can put this battery additional to your existing system. Other than feed-in tariff, also have net energy metering, net energy metering. So for this residential, to add more apa kata new technology into your existing system is a good to have, because in future, who knows, if let's say the retail side, when they have an open market, so everybody need to buy your tariff. You can choose whatever tariff you want to ni, and this battery system can support all these residential people to have their better or in the efficient using of this electric. That's what ni lah. So our plan is just now I showed other than this battery, and also we have tried to see also on this electric vehicle, because you know that electric vehicle also use a battery. Okay, I think that's the short answer that I give to Cik Arif lah.
Okay, thank you, Cik Fikri. Actually, we have another 11 questions here. However, I think we can only answer a last question here from Aina Sarah, which is, have TMB considered in solar, wind and BES hybrid system for rural energy electrifications?
Okay, regarding on this question, thank you for the question also. It's a good question. So right now, actually, for the solar hybrid system, actually the system itself is a lot of the solar hybrid system are using at the rural area around the Semenanjung and also the peninsula and also on the Borneo, Sabah dan Sarawak. Okay, but all this project is funded or I can get funded by government because of this the cost of the project is expensive. It's too expensive, and people who are like if people who like to invest in this apa kata the system, they have to actually they think twice lah, because of if one if they means that other than apa kata it means that the investor lah who want to invest in the ROI to get the return for this system, they have to think more lah. That's why in our our company we operate I think how many site I think 40 or 50 site in the peninsula Malaysia, at the rural area, at the island, most of the system at Mersing ada for this solar hybrid system. Okay, actually they have if you say that TMB consider, I think if we want to invest in this we have to think more lah, because actually in term of the cost, in term of the maintenance, in term of the collection of the when we are supply the electricity to the consumer, that's they have to put into the financial model lah. But I think for my opinion, TMB will not go into this solar, wind, and also BES system for this rural energy education. That's my thought lah. Okay.
Okay.
Because of the ROI lah, in terms of the ROI.
Okay, thank you, Encik Fikri. I believe once all the cost is coming down, there are possibilities for us to adopt this kind of, I can say, hybrid system, which is include the solar, wind, and the BES hybrid system itself lah. Okay, so I think that's all the time that we have today. We already passed for 30 already. So for others question, which is I believe we have another about 10 more questions actually that we are unable to answer here. For the participant that have question, you can drop your emails at the chat, and then we will look back your answer, your question, and we will come up with the answer, and we will email back to you. So hopefully you can drop your emails at the chat. Okay, so for this evening, I believe we appreciate if we can have one photo session. So can everybody open your videos for us to have a photograph sessions this evening?
So okay. No one asked about the price of the battery. So just to share lah, for our installation battery system at our training facility is around 70,000 RM for only a small battery, 70,000. So you can see the how the price if you want to install the battery system in Malaysia lah. Okay. So Cik Zarif ke yang will have to?
Yep.
Okay. So everybody
Okay.
can
Is it
smile.
everybody ready? Okay. If everybody ready, I will take a snap. Okay. For the first page, we have about how many page here? Hold on. We have about almost 3 page here. So hopefully everybody can stay their smile. Okay, so I will start with the first page. I do not know who in the first page. Okay, so just keep smile, thumbs up maybe. Okay, we count on 3, 2, 1, snap. Okay, that's settled for the first page. Okay, so for the next page, hopefully the next page is ready. Okay, with the count of 3, 2, 1, and I snap. Okay, for the third page, for the third page, I believe is fulfilled with people does not open the camera, but I just take their name as a representing today's session. Okay, I just snap here. Okay, so thank you all for the photography session. All right, so
Okay. Thank
back
you for
to
joining us.
Mr. Fikri.
Thank you all of you for joining us in this mini class session. So hope that we can see you in future, maybe the full course training. I think you can maybe next year, inshallah. So hope all of you stay at home, good in health, and assalamualaikum warahmatullahi wabarakatuh. Thank you all. Thank you.